Today on IODP Expedition 342, Newfoundland.
Pressure to rotate just a bit while the drill string stays steady. And they do that with a lot of directional drilling. And occasionally...
What if they let me swing up there, huh? Just grab onto these guys?
To be here on this boat myself for the first time, really, it's amazing because you really understand the magnitude of the science that is happening and has happened here. And as a scientist, it's really remarkable to be in such an environment and on a vessel that has been so significant to Earth science. It's a floating ocean lab. And the friendships and the collaborations that we develop on this boat are things that we carry with us for the rest of our careers and our lives.
Now, when we're going into Newfoundland, we'll be going up into the Labrador current and then down along the side. Just for a reference with regards to the currents that we'd be working with as we were steaming to this site. You see my last position there at 0800, and we're just coming along towards our first location, and then operation starts.
Forward on deck.
I'm so obedient.
Beautiful, that core. Now I'm ready to go to bed.
First core, so the first shot into the seafloor, comes up and everyone's all excited. A lot of us got up early even though we weren't on shift because we just wanted to see the first piece of sediment. It's hard to describe that we're so excited about mud. And even the first mud that we collect isn't even the mud that we're most interested in, but it's the official start to the expedition, really.
Welcome to Titanic Tales again, and today we're going to look at some images from the seafloor around the Titanic wreckage site. And if you look at this image, which was published in National Geographic earlier this year for the anniversary, you can see right here this dark spot, and this is the bow of the Titanic, and this is the stern. And there's various other pieces of the ship here, but that's not really what interests me. What interests me, I'm a sedimentologist on this expedition, and what this image reveals is what the seafloor looks like in a lot of detail. And what we can see when we look at this are these shapes here, these sort of triangular shapes, and this is zoomed in over here. You can see them right here, these shapes here, which are erosional features on the seafloor. And so what this tells us is that these currents, these deep currents that interact with the seafloor, are producing erosional features and depositional features. These currents are interacting with the sediments on the seafloor, redistributing them, and it tells us about the strength of the currents and what direction they're coming from. And so with this expedition, we're going to drill deep into these sediments and hopefully get a history of these currents by looking at the characters of the sediments in the cores.
Looking at the first sample, Dick?
Yes, this is the core catcher.
Extremely tiny forams.
No, it's barren, completely barren.
Actually, I can find only diatoms.
We're looking for little tiny fossils about the size of the biggest ones would be about the size of a pinhead, and they're made of a mineral called calcium carbonate. These are our primary means of indicating how old the sediments are at this stage.
What we have here is a poster that will hopefully serve as a talking point for the science crew. We've got the time scale for the last 65 million years with about 4 different measures of time, magnetics, and 3 different types of microfossils. And we also have plate tectonic reconstructions corresponding to certain times in the past. Now, from what we can tell from the first core, we know that the sediment falls somewhere into this first 65 million years.
The Paleogene, this period of time that we're studying, that's from 66 to about 23 million years ago looked very different than today. There were large tropical oceans and subtropical oceans, and polar oceans were much smaller. But as we progressed through this time period and we got closer to where we are today, those tropical oceans closed and polar oceans opened up, like the Southern Ocean, and here in the North Atlantic where we are, the oceans got wider and deeper. So the focusing and transport of heat on the planet by wind and by water was much different at the beginning and at the end of this Paleogene period. And so that's really interesting because it feeds back into these climate change events that we're studying, to trying to interpret and understand these climate events that we're uncovering in these ocean cores.
The reason for the excitement is that we've hit some really juicy targets. First hole, first site, 3 major stratigraphic events that everyone's excited about.
We have the pre-PETM interval, and then we have the onset of global warming and ocean acidification with these fine layers running through the record. And then we go back into this red material, okay, this pinkish stuff, which is the period of time when we still had a fairly acidified ocean. And we expected this. This is something that we anticipated we would find. And there was a major reason, actually, for drilling this site, was to identify these sort of what we call a rebound effect, where the ocean begins to dump massive amounts of calcium carbonate out after this severe climate change event. So that's very cool. This is just Hey Caitlin, we need to do some sampling here. You know, how much time do you need?
Well, Horatio and I were just wallowing in the warmth of the Eocene and checking out these awesome Eocene cores that we just brought up.
Okay.
All right, so we'll be out of here in just a second. Come on, Horatio. You know, we just have a couple more minutes to look at this core that's actually from the Eocene, the same time that this little guy, Horatio the Hyraxtherium, is from. The Eocene was about 55 million years ago, and back then it was so hot. It was so warm that Horatio and other little Hyraxtheriums used to scurry around in the forest that was all the way up to the Arctic. And you know what else? Horatio and all of his cousins actually turned into modern day horses. Horatio, you're so small, but all your cousins today are so big. I can't even believe it. Well, I think Dick needs to come in and take a few more samples, so we better get going and see what else is going on the JOIDES Resolution. Business.
It's hard to stay on top of the workflow because these cores are coming out and we're seeing these really exciting events like the ELMO and the PETM and the KPG boundary for the first time. Many of us had never seen these events before, and so we're like, oh, let's check out these cores. But we also have to be constantly doing the workflow. So it was this challenge between having these discussions around the core and getting our work responsibilities done. But it's going well. We're kind of, the pace is a little more gentle now, and we're easing into the next site, I think.
I'm fine. Sunday barbecue.
Bit of burger, bit of sausage. Just woke up. Breakfast. Cheers. Probably be the burgers. Big. Juicy.
Texas quantities, Dan.
Life is fantastic.
We're looking at the KT boundary. This is the geological boundary between the Cretaceous and the Paleogene. The boundary where the dinosaurs went extinct, but a bunch of other things happened. There was a meteorite impact. It looks like we have captured in this core the ejecta from that impact event.
Dinosaurs? No dinosaurs. Dinosaurs? No dinosaurs.
Predictions bore out. Hole in one. We can go home.
I'm excited for the next core, believe it or not. I'm still overwhelmed by dealing with our first core. There's a lot of excitement packed into those 270 meters of mud. But I'm ready for the next one and see what stories it has.